In this video, I'm just going to do 3 more examples. One of the examples is from the homework. It's not this one, but it's coming. So in this example, we are told that f prime is equal to this function, and also that f of 1/2 is 0. So, and then we're asked to find f of x. So clearly, if I take the derivative of f of x, I get f prime of x. So this question is basically asking us to find the antiderivative of this function, and we're being asked to find the specific antiderivative such that f of 1/2 is equal to 0, which means that we're going to use this to find c. So let's start that process. So the first thing I notice is this, it's not immediately obvious to me what function this is the derivative of. But if I were to look at my table of derivatives or my table of antiderivatives, I would recognize that 1 over root 1 minus x squared is actually equal to the derivative of the arcsine function. Okay, so if you notice this, then you say, hey, if the derivative of arcsine gives me this guy, that can actually help me work backwards and say that, okay, the antiderivative of this function is arcsine x. And so that's what I'm going to use here. That's why it's good to know your derivative formulas really well. So in this case, I see that f prime of x, which I can write as 6 times 1 over 1 minus x squared, I want to find the antiderivative. Okay, and in this case, I can see that f, I'm just going to use this notation f, just because we already have the notation f prime. So we are changing notation from what we did before, but this is going to be 6 times arcsine of x plus c. So my first step is to find the most general antiderivative, because that's the first step before I look for a specific or a particular antiderivative, which I know that I need to do because of this condition given here. Now, we know that f of 1/2 is equal to 6 arcsine of 1/2 plus c, and that is given as equal to 0. Now, this equation I have to solve for c. Arcsine of 1/2 is pi over 6, because sine of pi over 6 is 1/2. So this tells me that pi plus c is equal to 0, or c is equal to negative pi. And now finally, my antiderivative is f of x equal to 6 arcsine of x minus pi. And as always, I'm going to check my work. I'm going to take the derivative, so f prime of x is equal to 6 times 1 over the square root of 1 minus x squared minus 0. Okay, and that indeed was the original function here, so that matches up. And I also want to check that f of 1/2, which is 6 times arcsine of 1/2 minus pi, and I just want to check, is that actually equal to 0? So in this case, I have 6 times pi over 6 minus pi is equal to 0, and that checks out. So here is another example where I am told that the second derivative of f is equal to 3e to the x plus 2. The first derivative evaluated at 0 is 3, and f of 0 is equal to 1. So I'm given f of 0, I'm given f prime of 0, and then I'm given the second derivative of the function. And our goal is to find f. Now, so you can see that clearly f is an antiderivative of f prime, and clearly f prime is an antiderivative of f double prime. And these conditions we're given here are going to allow us to find constants. Okay, so our goal is to find f, a specific antiderivative, um, and we're looking for a specific function, not our final answer will be a specific function f, not like a most general, but we will be using the most general antiderivatives in order to find f. So let's get started on that process. So I'm going to start by just writing down the second derivative. Okay, and if I go back a step, I am going to, so let's find f prime of x. I'm just going to find an antiderivative. So what is the antiderivative of 3e to the x? Well, we have a constant multiple, and then we have e to the x. So in this case, 3e to the x is the antiderivative of that term. And what is the antiderivative of 2? Well, what do I differentiate to get 2? So that would be 2x. And then I need a constant c. Okay. So now we were also given that f prime of 0 is 3. So I'm just going to use that information here. And I'm going to say f prime, so let's use this information. F prime of 0 is equal to 3e to the 0 plus 2 times 0 plus c, and that is equal to 3. So what I have here is 3 times 1 plus 0 plus c is equal to 3. Or in other words, 3 plus c is 3. So c has to be 0 in this case. So in this case, my specific particular antiderivative of f double prime is 3e to the x plus 2x. But we want to go a step further because we want to actually find f. So let's take another antiderivative, and here I have f of x. So what do I differentiate to get this guy? Well, it's the same as what we just did, 3e to the x. And what do I differentiate to get 2x? Well, that's doing the power rule backwards. That's just x squared. And then I have another, I'm going to use a different constant here, d. So d is my new constant. And I'm going to now use the fact that f of 0 is 1 to allow me to figure out what d is. So we have f of 0 is equal to 3e to the 0 plus 0 squared plus d, and this should be equal to 1. So solving this, we get 3 times 1 plus 0 plus d is equal to 1. Then I have 3 plus d is equal to 1, so d is equal to -2. Okay, and this implies that my final answer is going to be f of x is equal to 3e to the x plus x squared minus 2. And then that would be my final answer. So I'm going to check that. Okay, so let's just check. So we have f prime of x is 3e to the x plus 2x minus 0. And then I have f double prime of x is 3e to the x plus 2. So that checks out. That is exactly what I had for my second derivative here. Okay, and then my first derivative also checks out. And I also want to check, is it true that the f prime of 0 was equal to 3? I'm just going to double check. F prime of 0 was 3e to the 0 plus 2 times 0. And was that equal to 3? And indeed, this was 3 times 1 plus 0, and that is equal to 3. So that checked out. And then I'm also going to check my other condition. Is f of 0 equal to 1? So let me just double check that. 3e to the 0 plus 0 squared minus 2. Is that equal to 1? I have 3 times 1 plus 0 minus 2. And then I have... that's just 3 minus 2, so indeed this checks out. Okay. So this example is from the homework, and we're being asked to find f once again, and we're given the second derivative, and we're also told that f of 0 is equal to 0 and f of pi is equal to 0. So unlike the last example, both of these are f of 0 and f of pi. We're not given any information about f prime. That's okay, we can still figure it out. And remember also, don't let the notation confuse you. So if I have if I take the derivative of f, I get f prime, and if I take the derivative again, I get f double prime. So basically, this is an antiderivative, and this is an antiderivative. So the notation is a little different from the first video, but really the process is the same. You're just working backwards, and you're trying to figure out the antiderivatives. And we use this, this information just allows us to find specific functions with constants. So let's start this process. I'm just going to rewrite my function in red just to remind you guys that, this is the function whose antiderivative I seek. So let's start here. So f prime of t. So the antiderivative of this term is just 9e to the t. We know if we differentiate this, we get 9e to the t itself. So what do I differentiate to get 5 times sine of t? So remember that I can pull the constant multiple out, but remember that the derivative of cosine is negative, or is negative sign. So in order to get a positive sign here, I actually, the antiderivative of sine is actually negative cosine. So that takes a little getting used to. And then I've got to have some constant. So this is the most general. And normally I would, in the past examples, we've had like f prime of 0 is equal to something, or f prime of 1 is equal to something, which allowed us to figure out what c was. But actually, we don't have that in this case. So I can't plug anything in to find c at this point. So I'm just going to clean this up a little bit, and I'm going to and then I'm going to keep going. And I'm just going to leave the c there. And I'm going to go through the process again, and I'm going to try to find the antiderivative, the most general antiderivative of this function. And that would be f. Again, this is the easy term. And what do I differentiate to get cosine t? Well, just sine t. And what do I differentiate to get a constant c? Well, c times x. And then I'm going to have another constant d. Okay. Now I'm going to try to use this information to help me figure out what c and d are. So let's use this condition first because it's easy to plug in zeros. So f of 0 is equal to 9 times e to the 0 minus 5 times sine of 0 plus c times 0 plus d, and this we're given is equal to 0 also. Okay, so in this case, I have 9 times 1 minus 5 times 0 plus d is equal to 0. So this gives me 9 plus d is equal to 0, or d is equal to negative 9. So that's nice. We actually found what d is equal to. So let me write that down now. So this implies f of t so far is 9e to the t minus 5 sine of t plus cx minus 9. I still don't have c. So now I'm going to use this other condition, which tells me f of pi is equal to 0. So let's do that. And this is equal to 0. So let's just clean this up a little bit. 9e to the pi, not much I can do there. Sine of pi, remember the y-coordinate there will be 0, so that's 5 times 0, plus c times pi minus 9 is equal to 0. And I need to solve this for c. So let me just clean this up a little bit. 9e to the pi, this is just 0, plus c times pi. I'm going to bring this over to this side. That's equal to 9. And I'm also going to bring this term over. So I have c pi is equal to 9 minus 9e to the pi. And I can isolate the c. So I'm left with 9 minus 9e to the pi over pi. Okay, so that is c. It's a mouthful, but there it is. So I'm just going to go back up here to my original function. I'm going to 9 minus 9e to the pi. And that's the value of this guy, c, right here. So let's write our final function down. And I'm just going to use this version actually. And fill in those constants. So in this case, we have, going back to the original function, 9e to the 9e to the t, 5 sine t plus c, which was found to be 9 minus 9e to the pi over pi. This whole quantity will be multiplied by t. And then d was negative 9, so minus 9. And then this is my final answer. And what you can do is make sure to check everything checks out. I'm going to leave the check up to you guys.